Welcome back to Smith Coding and Design. This is our third tutorial. Today we are going to go through all of the toolpaths in Op1 and we will understand why we decided to create these circular patches in the previous tutorials. So with that being said, let's jump in. So the first thing I'm going to want to do is go ahead and remove all the material from the top of the shield. So to do that, we are going to be using a 3D spiral toolpath just because I like the way the surface finish works. So I would like to go ahead and share that with everyone. So we're going to go to 3D spiral. I'm going to go to my tool library. I'm going to go to my 770 and then I am going to select a 3/8 3-flute Gorilla Silverback. Click OK. We're at 7,500 RPM. I'm going to go 60 inches per minute. So we will want to come back to the geometry tab in a minute, but I'm going to leave it as it is for now, just so that you understand why we want to use that circular patch. So now if I go to the heights tab, model top is fine and model bottom is fine, again because we will be using that circular patch. So everything else in this toolpath I am going to leave default, except I will go ahead and enable smoothing and feed optimization. So everything else will be default. I'm going to click OK. The toolpath will generate, and now we'll understand exactly why we are using the circular patch. So if we look here, we notice, let's go ahead and right click and simulate, that there are a lot of Z retracts which I want to avoid, and you'll notice that we are going into the pocket in the center there, which I don't want to do. So you see that we're going in to that center pocket. I want that center pocket to be one 3D pocketing toolpath where I use a 1/8 inch end mill, and I want the top surface finish to be as smooth as possible. So again, go ahead and drag just a little further here. That is why I want to use the patch, to prevent the tool from going into my part and to get a nice smooth surface finish where we have a continuous machine motion without all of the retracts in Z. So I'm going to exit, and all we need to do to achieve that is right click on our toolpath, go to edit, and then if we go here to geometry, we just want to go ahead and enable model, and then we want to expand our models tab to the left here. Let me just close everything so we can see. And then we want to go into our fixture for Op1. So we'll expand that. And then we want to expand our Hylian shield and choose the top patch. So now if we click OK, you'll notice what happens here. Let me close this. We'll go back to the toolpath. So now you notice we get this nice smooth motion where we are only finishing the top surface. There isn't a bunch of retracts in Z, and we are not going into this center pocket. So that's what I want, just a nice smooth toolpath with a continuous motion to try to get the most visually pleasing surface finish that I can get. So what we'll do is we'll go ahead and right click and simulate so we can see that now. And again, we're taking this in one pass, so we will be at a 50 thousandths depth of cut. So now I'm just going to go ahead and move the timeline here, and you can see we just start in the center and then we just slowly spiral our way out. All right, and so I will point out here, if you look at the edges, we are sort of inefficiently, we're not cutting air because we are sort of facing the stock, but again, it's inefficient in the fact that we do machine that whole circular patch and not just the area that our part is on. Again, I think the inefficiency is worth a better surface finish in my opinion. Let me know what your thoughts and opinions are in the comments below. All right, so that is it. We're going to go ahead and exit the simulation. Everything looked good there. So what we're going to do now is we're going to do a 2D adaptive clearing, and we're going to go ahead and rough all the material around the shield away. So I'm going to go to 2D adaptive clearing. We're going to go back into our Toolpaths library, and then we are going to select our 3/8 3-flute Gorilla Silverback end mill. So we're going to select OK. we're going to be at 75 RPM, 60 inches a minute. And again, it might be a good idea if you have a tool changer to separate your roughing tool and your finishing tool. I don't, so I'm going to use the same tool just to minimize the amount of tool changes that I need to do, because that means I have to be at my machine babysitting it for a longer period of time. All right, so with that being said, let's go to the geometry tab. We're going to select the bottom contour around the outside of the shield. We'll then go into our heights tab. We've removed all the material from the top of the shield, except if you remember, there were some pieces of material on the corner there that weren't removed. So I'm going to leave it at stock top for now, just because there was that extra material on the edges there. And we'll go back and look at that here in a second, just so you understand what I'm talking about. So we're going to leave it at stock top, leave the bottom at selected contour. All right, we're going to change our optimal load to 40 thousandths. Again, arguably the most critical parameter for our adaptive clearing toolpaths. We don't want to stall our spindle. So I'm going to use 40 thousandths. If you have a machine with more horsepower, of course, you are going to use a larger optimum load. And again, I like to keep that at around 10% of the diameter of the tool. So moving on, stock to leave, I'm going to leave 10 thousandths. And then I'm going to enable smoothing and feed optimization. And again, really, because we're just doing the outside here, I'm going to go ahead and not leave anything on the floor, but leave 10 thousandths on the sidewall so that we can finish those. So that's good. The last thing I'm going to do, actually, I don't want to enable smoothing and feed optimization because this is a roughing toolpath. There's really no reason to do that. So I'm going to go into the linking tab, and I want to change my ramp clearance height to 20 thousandths, just in case we do any type of ramp or helical entry, which we're probably not going to, since we're just clearing away the material on the side of the part. We don't cut air, so I just do that out of habit. We'll go ahead and click OK. And then there you have it. We simply remove all the material from around the shield, and we leave 10 thousandths here on the walls. That way we can go and clear them, or sorry, go and finish them here in a second with a 2D contour. So we're going to go ahead, right click and simulate. And again, I'm just going to use the timeline. So here is the material we left on the edges where our circular patch did not extend past our stock. So that is why I chose stock top as my top height, just because there are portions of the stock that have not been touched. So with that being said, let's go ahead and just sort of walk around our toolpath here using the timeline. And so you can see it's nice and smooth, just going ahead and roughing in the outside of the shield. So there you go. So now what we need to do is come in and finish our walls. So I'm going to exit the simulation, and then we're going to go to 2D contour. Again, I don't have a tool changer, so I'm sticking with the 3/8 3-flute Gorilla end mill. So here we go, tool 8, 3/8 3-flute Gorilla Silverback. So we're going to select that. I'm going to go 60 inches per minute. Sorry, we're going to stay at 30 inches per minute since we are just finishing the walls here, and I want to get as nice of a surface finish as I can get. So we can go slower. It's going to be a quick tool path anyway. 30 inches per minute, not 60. So 7,500 RPM, 30 inches per minute. That gives us right around 1.3 thou per tooth. We'll go to our geometry, and again, we're just going to select the bottom contour around the outside of our shield. So that's good. We'll go to our heights. Of course, we've removed all the material around the shield and the material off the top. So now we can go ahead and choose model top. Select a contour for the bottom height. That's perfect. We'll go into passes. And here what I'm going to do is go ahead and add a finishing overlap of 50 thousandths. I always like to do that just to try to cover up where I enter the toolpath, or if there's any artifacts there, I sort of overlap by 50 thousandths. So the next thing I'm going to do is go ahead and enable smoothing and feed optimization, and then I'm just going to go ahead and click OK. Actually, I want to add in I want to change my lead-in sweep angle to 45 degrees. Sorry about that. And now we will go ahead and press OK. And so there you go. We just cleaned or finished the outside of our shield. So we'll go ahead and simulate. And again, here we're just going to take one pass and remove that 10 thou worth of material from our walls. Beautiful. So I am good with that toolpath. So now what we're going to do is go ahead and get into really the main toolpath, which is clearing the pocket here in the center. So the pocket itself is 80 thousandths deep, which provides, in my opinion, just enough room for the epoxy to go into, and the side walls or the wall thickness around the Triforce and some of the other shapes here is 30 thousandths. So with that being said, let's go ahead and get into our pocketing toolpath. So I'm going to go to 3D pocket clearing. I'm going to go to my tool library, go to my 770 library, and I'm going to choose a 1/8 inch 3 flute end mill from Char Tools. Again, I broke this tool in the overview if you saw one of my bloopers. So we're going to go nice and slow here and leave the feed rate at 30 inches per minute, although we will take the spindle RPM and go as fast as we can go. So the most of the 770 can give me is 10,000 RPM. I think that's even the max the 1100 can give. So we're going 10,000 RPM, 30 inches per minute, which gives us right at 1 thou per tooth. So moving on, we will need to come back and edit the geometry tab, but for now I'm going to leave it as it is so we can sort of leave it as a learning experience. Because it is a 3D pocket clearing toolpath, you'll notice that Fusion will essentially try to machine all of the geometry for us, and we only want to contain the toolpath to everything inside of the shield. So we'll come back and change that in a minute, but we'll leave it as it is for now as a learning experience. So for our top height, I'm going to select a model top since our top has been finished and all the material around the side of the shield is going. It's safe to use the model top. We'll go into passes here. Now I do want to enable manual step over. I'm going to go 50% the diameter of the tool. The next thing I'm going to do is go ahead and change my maximum roughing step down, and I'm going to change that to 20 thousandths. All right, and I'm not going to leave any stock, and I'm going to enable smoothing and feed optimization. And then if we go here into linking, we'll see if we have the ramp clearance height. It's at 21 thou. I'm just going to make that 20 thou. That's what I always use. And then we'll click OK. And now you'll see why we want to go back and change that geometry tab. Again, because it's a 3D toolpath, Fusion took into consideration all of the geometry of our part for us, and it tried to machine the outside, and that generated a 3-hour toolpath, which is definitely not what we want. So what I'm going to do is right click and edit, and all we need to do is go back into geometry and change our machining boundary from bounding box to selection. We're going to select the outside contour along the top of our shield and press OK. And now we should drop down to around a 40-minute toolpath, 38 minutes. So again, we are just finishing everything on the inside here. And so that is it for the pocket. So now all what we really need to do, or what we're left with, is just a series of chamfering toolpaths. So what I will say, this toolpath is rather long, 38 minutes. Again, I did order some high feed end mills from Helical Tools that are meant for aluminum. So in the future, I'm going to use that and see if I can drastically reduce the time it takes to perform, a pocket with complex geometry like this. If I could half that 38-minute cycle, I would be happy. So with that being said, let's go ahead and hop into our chamfering toolpath. So I'm going to go to 2D. I'm going to go to chamfer. I'm going to go into my tool library, into my 770 library, and I'm going to select my 1/4 Gorilla Tool Lemur Chamfer. I'm going to select OK. We're at 4,000 RPM, 20 inches per minute. That gives us right around 1.25 thou per tooth. The surface feed is always there if you're interested in that. So now we will go into the geometry tab. So we'll actually do 2 chamfering toolpaths, one where we sort of get the main contours, and then with the 30 thousandths walls here, we'll come back with another chamfering toolpath and really just kiss those. So here I'm going to select the holes as well as the outside and sort of the inside large chamfer on the top of the shield. Okay, so that all looks good to me. So I'm going to go ahead and go to our heights tab. I'm going to change stock top again to model top because we removed all the material. We're going to go to our passes tab here, and I want a 10 thou chamfer width. All right, so that looks good to me. I'll go ahead and enable smoothing and feed optimization. And last but not least, I want to change the lead and sweep angle to 45 degrees instead of 90 degrees. Click OK. And so that is our first chamfering toolpath. So now what I want to do is go ahead and chamfer all these walls on the inside, just because I've noticed when I did my epoxy pour, the epoxy doesn't go all the way to the top of the wall, even though you'd like it to, and you know, the perfect scenario. So I want to make sure there's no sharp edges there where, you know, especially since my son likes to play with it, I don't want him to cut his finger or anything like that. So what I'm going to do here, just to save time, we're going to right click. We are going to say duplicate, or you could Control D for duplicate. And then we'll go ahead and edit. And really, we're leaving all the parameters the same. We want to go ahead and clear the geometry. We want to start selecting all of the geometry on the inside here. So really all of the cool aspects of the shield. And again, you can see the collars there. And that's the collar that the epoxy was. So I tried to make the shield look as close to what it would in real life as possible. All right, so that all looks good to me. So now what I want to do, again, we use the same exact toolpath and duplicated it, so our top heights are fine. However, if we go into passes here, I do not want a 10 thou chamfer width. I want to go 5 thou. I just want to kiss those edges there and make sure there aren't really any, you know, burrs or sharp corners. So I'm okay with that. I'm going to go ahead and click OK. And so that does it for Op1. So what we'll do now is we will go ahead and view the Tormach doing all this machining. Please let me know any thoughts or comments, what you liked, what you didn't. And again, I will catch you guys in the next tutorial. Thanks. Please like and subscribe. All right, so now we begin our 3D spiral toolpath using a 3/8 3-flute Gorilla Silverback end mill, 60 inches per minute, 50 thou depth of cut, and 94 thou for width of cut. Again, we're using a continuous smooth spiral motion. We were able to accomplish that using the patches from tutorial 1. And so you can see the surface finish is nice and beautiful. It's really my second favorite after the Superfly. The Superfly gives you a nice mirror finish, but the 3D spiral and the 3D radial toolpaths really give you sort of a unique aesthetic look, which I do enjoy. So what we'll do next is we will transition into our 2D adaptive clearing, and then we'll go ahead and remove the material around the outside of the shield. Alright, so here's our 2D adaptive clearing, same 3/8 3-flute Gorilla Silverback end mill, 60 inches per minute, half an inch for our depth of cut, and 40 thou for our optimal load or our width of cut. Again, we'll sort of jump through the toolpath here to the interesting portions as it is long, and we're really again just removing the material that is around the outside of the shield. And there again you can see that beautiful surface finish from the spiral toolpath. And now we will start to transition into a 2D contour. So we're finishing our sidewalls. Same 3/8 3-flute Gorilla Silverback end mill, 30 inches per minute, half an inch depth of cut, and 10 thou for our width of cut. So we're really just cleaning up the tint thou we left on our walls to get a nice surface finish. So we'll go ahead and we'll continue with this toolpath, and then we'll get into the 3D pocket, which is really where most of the machining occurs. Alright, so here we are with the 3D pocket. We're using a 1/8 3-flute Charzen mill, 30 inches per minute, 20 thou depth cut, and 50% the diameter of the tool for our width of cut. Again, this is where most of the machining occurs. It is the longest tool path, so we will kind of skip through most of the machining here, but you can see the inside of the Hylian shield start to take shape. And again, this is where all the complex geometry is. The surface finish in there also looks beautiful, but it's not as critical since we will be filling it with epoxy. So what we'll do now is transition into our chamfers, and that will finish Op1. Alright, so here is our first 2D chamfer. We're using a 1/4 inch Lemur Chamfer mill from Gorilla Tools, 20 inches per minute with a 10 thou chamfer width. So we're doing that for sort of the large chamfers or the large contours on the inside of the shield and on the outside and around the holes on the top surface. The sidewalls for all the geometry on the inside of the center pocket is really 30 thousandths, so we'll come through next with another chamfering toolpath. So here's that chamfering toolpath. It's the same tool, 20 inches per minute. We're just going 5 thousandths for a chamfer width, so we can go ahead and just kiss those 30 thousandths walls and remove any sharp edges. Again, in my experience, after I poured the epoxy, it usually doesn't go 100% flush with the surface, so you can sort of fill the tops of those walls. So I just wanted to make sure that there are no burrs. So that's it, guys. I hope you enjoyed. Please like and subscribe, and I will catch you in the next tutorial.